Alrighty. So number 5, calculate the molarity. Remember, molarity is big M, of a solution consisting of 45 grams KNO3 and 2 liters of solution. So we have grams and we have volume and we need molarity. So we know we need molarity, which is moles over volume. We have volume right here. What we need is moles. How can we get moles from 45 grams? So that's what we're going to work on. So we need we need moles of KNO3 so that we can find our molarity. So we need moles. We're given 45 grams KNO3. And how do we get rid of grams? What do we put on the bottom here? Well, he gives us a molar mass. We have 101 grams of KNO3 per 1 mole of KNO3. So if we cross out our grams of KNO3, we're left with moles of KNO3, and that's what we need. So how many moles is that? That looks like, oh, okay. Sorry, my calculator just stopped working for a minute. Okay, so I'm gonna restart it. And one thing that we can do here is we can also find, we're trying to find molarity, right? We need molarity. We're given 2 liters of solution, and we know that our equation is moles over volume. So we can actually put 2 liters on the bottom. Now we have moles on top. We have liters on bottom. Okay, let's see if my calculator works now. Okay, so now if we multiply across, we have 45 divided by 101 times 2, and we get 0.223 molarity. And that's A. All right. If you have any questions on number 5, on how I did that, just email me and I'll send a more detailed video. Number 6, calculate the moles in the mass of solute in 500 milliliters of 2 molarity. Okay, so we need to find moles and mass. And we're given a volume and we're given a molarity. So let's focus on moles first, because if we do this equation, we can get moles. We just have to rearrange it. So we just multiply out the V, and we get M times V equals moles. So we have 2.00 molarity times 0.500 liters, and that gives us 1 mole. So we have 1 mole of H2SO4, and we know how much 1 mole of H2SO4 weighs. It weighs 98.1 grams. So we need 1 mole, 98.1 grams. All right, number 7, and then after this I'll start another video. How much water must be added to 300 milliliters of a 4 molar NaOH solution to obtain a solution that is 2 molar? Okay, so this is when we want to do the dilution equation, right? Remember, the dilution equation tells us this. And we just have to pluck out those variables. So how much water has to be added to 300 milliliters? So this is going to be a volume 1. We want to find a volume 2. That's how much water. And this is M1, and this is M2. So if we want to solve for V2, all we have to do is divide out M2. So we're gonna have M1V1 divided by M2, and that's gonna tell us our volume that we needed to know. So our molarity 1 is this, and then our volume, and since the answers, if you'll notice here, the answers are in milliliters, I'm just gonna keep my volume in milliliters. So we have 300 milliliters, and we're gonna divide it by the second molarity, which is 2.00, and we get, now it says, we want to get, sorry, just my calculator keeps freezing. So we need to do 300 milliliter solution. I can't math in my head. Okay, so that gives us 600 milliliters, right? 12 divided by 2. And that's going to be our total volume, right? So this is actually 600 milliliters is our total volume, but we don't want the total volume. It's not asking what is the total volume. It's asking how much water has to be added to 300 milliliters. So if our total volume is 600 milliliters, well, we need to know how much water was added. And we started out with 300 milliliters. So we just subtract that. And this is all in my head, so if this math up here is wrong, please check it for me. So I got an answer of 300 milliliters, and I will start number 8 on the next video.